So first of all, just for convenience sake, I put some definitions at the top. These are straight from Wikipedia. I cherry-picked some nice definitions for people who might not be familiar with what all these terms mean. So obviously Git, it's this version control software we're using. GitHub is the website. Secure Shell, so SSH, is a means of communicating securely over the internet. Fork is Project Fork is what you do to fork, aka make a copy of a repository for yourself. Branching, meld, or branching you might use, you might not use. It is a way of having multiple different versions of the code that you're working on at the same time. Meld is a tool for handling what's called a merge conflict. It's just the one I happen to use. It seems to be the only one that works the way intuitively for me. You might decide you like a different tool better. And let's see, a repository clone, aka repo. So repo is defined here. So it's the entire repository. A lot of this might be rudimentary. I don't claim to be an expert in Git by any means. I just happen to use it the most out of our team, and I've set up the repositories that we're using right now. So here's a very, very simple, easy guide. If I'm guessing that all of you have done all of this already, but just for sake of argument, if you make your GitHub account, and then if you haven't already set up an SSH key, I highly recommend you do that. This link here, it tells you how to do that. That will enable you to generate a public and private key pair, and you will copy and paste your public key onto GitHub's server, and that will enable you to easily from the command line push and pull your data from GitHub to your computer, laptop, desktop, whatever it be, and not have to worry about any additional authentication. So it's really nice. Let's see if we have any questions. Oh, okay, so it says it's unreadable. Let me go ahead and increase that. We will go ahead and share this document also. So there we go, much bigger. So like I said, here's the terms. There's just definitions straight from Wikipedia, nothing fancy. And then the initial setup, I'm going to guess all of you have done this. If not, there's links on how to set up the SSH keys. You might not have done that. You might just be doing it through HTTP. But there's that. So there's a guided walkthrough with some screenshots of how to fork the repo. I'm guessing you've all done this also, but just in case it's there. So once you click fork, you'll have your own copy of POSA 14, and it'll be your version. Now, here's the part where it starts to get, I wouldn't say tricky, but some people seem to be having some issues with it. How to clone the repo onto your local machine. So if you look at the main page, down here in the bottom right-hand corner, you'll see this box. By default, it's HTTPS. If you set up your public and private key pair above for SSH, you click the SSH button, and it'll change to this line here. You will click this button, and it will copy it to your clipboard. Okay, no more questions. And then you will go into the command line. Now, you could probably do this through the Eclipse UI, but I don't use that. I don't use it for anything other than importing the project. I don't think using the GUI part is beneficial in the long run until you've mastered individual parts of using Git. So push, pull, basic merging, things of those lines I feel comfortable with. But more advanced things, I still Google search how to do them each time I need to, so that, and I use that, and you will almost always find the command line answers for how to do that. So that's where I still highly recommend you learn how to use the command line, because that's when you go and you search, you'll probably find the answers on something like Stack Overflow, and those will always have the command line answers for you. But so you need to determine where you want the folder to go to. When you do, you will type the word git clone and then the custom URL from above, the git at github.com : and then your name, etc. And that will create your custom fork of the repo in your local machine. And then from that point on, you can do push, pull from your local machine to your personal GitHub account. Now, here's the thing I think everybody's having difficulty with: how to import the newest version from Doug's repository to your repository. Let me go ahead and read some of these questions before clone repo. Yes, no. Your fork will not track any additional code updates from Doug's repo by default. Miss Dell Anderson asked that. So no, that will not be handled automatically. But the next step of what I'm going to discuss will enable you to do that. So here's this link, and this is the book that you need to read. If you're going to be using Git and you actually want to be able to understand how things work and get more comfortable with it, read this book. I've skimmed through it probably 3 times and hit and pluck out parts that I've wanted to focus on multiple times. And so there's lots of things that you can learn from this book that don't make sense at first until you run into the scenario where you need to use them, and then they start to make sense later. And so here's actual command that you would type once you're inside the directory of your Git repo on your local machine. And so I'll go through what this command means. So Git, you're telling Git that you're going to give it a command. Remote means a remote repository. And so remote just means I'm doing something with remote repositories.
We need a window to show me the stuff. I've got mine open.
Oh, okay. Add the command that allows you to add a new repository. And then this line here is actually, you can make it whatever you want. I just call it POSA 14 public. You can call it POSA 14 Doug. I mean, it doesn't matter. It's a local, almost a symbolic link. It doesn't mean anything globally. And then this link here, this HTTPS, GitHub, and all of this. And so you type that, you hit enter, and what it does is it creates, normally you just do a Git Pull. You don't have any of this extra part over here. So you do a Git Pull, it'll pull from your repository on GitHub. But when you put this part here, this means what remote repository and what branch. So when you type this command, it will pull all the information in from Doug's repository into your repository. You will probably at that point have merge conflicts. So let's see. Okay, no more questions yet. At that point, you have to handle the merge conflicts. And how you in what branch, local branch, you decide to do the pull from the public repository and how you handle merge conflicts, that's really up to you and personal flavor. I would recommend creating a new branch and then pulling in the public repository into that new branch, and then that way any of the merge conflicts are handled in that branch, and then you can merge that branch into your working code, or at least that way you can compare them before you actually do the merge. So that's just a personal preference. You could do it all on master. You could do everything in the master branch. Completely up to you. So everybody has different workflows that they like. You'll just decide which pattern, basically, of workflow that you personally prefer. And I've left some hints here: how to create a branch, how to merge a branch, how to handle a merge conflict, because the topics are a little complex to be discussed here, but this is basically the definitive guide on how you do these processes, how you handle these tasks. Because I could give you a simple answer, but there's much more complex and authoritative answers on these here. Let's see. Okay. So this is the Git guide.
Is that showing up?
Yeah, okay. I just was checking. So this is how you handle branching. So basic branching is you have your master branch and you have different commits. And down here, when you create a new branch, it will point to the same commit as your master. But when you start working on that branch, the commits for that branch can be ahead of master. It goes through some convoluted, you need to do a hotfix for master and things like that. And I'll leave this up to you guys to read, but it explains how you merge different branches to get different branches to point to the same commit. And that you basically get rid of a branch. Yes, the branch D hotfix would delete that. And let's see. More basic merging. And here's where it discusses how to handle merge conflicts. So it tells you how to handle merge conflicts. You can technically handle them through any text editor because it does this complex formatting here, which you can just edit yourself, or you can use a tool such as Meld, which happens to be the one that I find the most intuitive to the way I think. I have it set up to bring 3 text editors. The one on the left is my original from my branch locally. The one in the center is the new result that I want, and the one on the right is the version that got pulled in. And so I use that tool, and whatever is in the center gets saved. And so that's just how it makes sense to me. You can find different tools that you like, and that's the trick with Git, is find the tool chain that you like to use the best. But definitely read this page here, the Git branching. You'll need to know how to do basic merging and whatnot. And then also how to undo things. Let's make sure that's showing up. Font size is 4. Okay, the undoing things. So this is really nice. Let's say you start doing some work and you just start editing the file, and you realize that you just want to undo everything you've done. You realize you've just made a massive mistake and you don't know how to fix it. If you read the documentation when it shows up in the command line, it actually tells you how to do this. But if you're using the the GUI, you wouldn't know. So that's another benefit. But right here's the command. So it's git checkout -- and then the name of the file or files. And that will allow you to revert any changes in that file easily. So that's a really nice feature of Git that we use quite a lot. And then the last thing I just wanted to cover was customizing Git. So this is really, really nice for command line usage. You can turn on colors. You can set your default editor. Do things such as setting your username and email. So any Git commit automatically has this new information. Lots of nice little, I wouldn't call them tweaks, but slight additions that you wouldn't think of doing automatically. In particular, the colors. That's really actually very useful because it'll show up green for files that you've added to that you've already added, and red for files that need to be added to a commit. Very nice, very convenient. And there's other things that you can do. You can customize the config so that you can change the color. So if you're colorblind, browns and reds are an issue to you, you can change those. You can change them to whatever you need to be. And then you can set your default merge tools. So if you don't like meld, you can change things of that nature. So let's see if there's any questions at this point. So where do we download this Git guide? We will go ahead and make this document. It's a Google Drive document. It's publicly viewable right now. I will see, how can I post? One second. Just copying this. And it looks like I was able to put it into the group chat during this discussion, but if not, we will go ahead and also post this on the somewhere on the course material. Where would you think would be the best place? Under the
is this about Git stuff?
Yeah.
There's a page which I'll, if you send me this stuff, there's a page that has instructions for installing using Eclipse and Git.
Okay.
Right there.
So we'll include that underneath of those or within that directory with that file. So let's go back to the questions. So Git. How do you prevent Git pulls from Doug's repo or GitHub repo from overwriting your previously completed assignments? So you have two options. By default, you don't, and they will just automatically conflict. But when they conflict, you'll have to open a merge tool to handle that conflict by yourself, or you can create a new branch and pull in the work there. You'll still get the conflicts, but then you can, in the new branch, you can safely just automatically accept Doug's updates. Then obviously you would have to merge between your branch and your, or the new branch Doug's work and your branch, which would require two branches or two merging, but it's a little bit safer that way. Okay. Okay, so we have a comment from Craig Duremus. I apologize for butchering your name, which I'm sure I did. Should emphasize that people should put their homework on a public repo like GitHub. That they need a private repo that is free, like on Bitbucket. That's true. GetLab also offers private repos, and GitHub will give you a free 5 free repos if you have an academic email, so a .edu email. So that would be a great way of doing that. In the future, possibly, there might be a Coursera Git thing, but who knows about that. But for right now, yes, you should definitely look at either GitLab or apparently Gitbucket offer free private repos where you can store your homework. It's not as important for you personally for your information not getting shared, but you definitely don't want to leak your information and have somebody else copy off of you, because that would definitely break any honor codes and things of that nature. Let's see, if we fork the clone version, does additional code be updated? I already answered that. No, if you fork the repo, code will not be automatically updated. You'll have to do those things. 3 decades of computing and people still like the command line. Yes, because the command line is better. The command line is, so if you're still using Windows, you might not be familiar with the command line. And if you're using a Mac and you choose not to use the command line, then that's fine also. But if you're on Linux or a Mac, Mac in particular is BSD based. So it has a full command line options just like Linux does. But if you use either one of those operating systems, the command line, you can do things in the command line that will only take you a couple of seconds on the command line, but would potentially take hours going through UI. So that's why people like the command line. And Git is another one of those features. Doing a Git pull on a different repo literally just says is two additional words, which will autocomplete. All you have to do is start typing it and hit tab, and it will finish typing the word for you. So that's why people like the command line. Plus, once you understand the command line, then you can transition to something along the lines of the eGit functionality within inside Eclipse, which is great because then, I can just right-click and select pull, and it does it for you if that's all you want. But you have more options and abilities on the command line, that's for sure. So how is the repo on my local machine different from the project in Eclipse? So I'm not quite sure what you mean by that, but I always recommend, so Eclipse by default will pull in, let's see, there we go. Eclipse by default will go ahead and pull in your project into what's called a workspace. I always tell it to not do that and to leave the code where it's at, to not pull it into the workspace. That way, any of the files you edit will automatically be changed in the same location as where your repo is, and that way it's a lot easier to do that way. I believe it does that automatically if you use eGit to import the projects. That's literally the only time I use the Git plugin for Eclipse. I'm importing projects because it then does tell you when your local repository is ahead of a remote master or anything like that. So it is nice for that regards. Let's see. Some welcomes, thank you. Change images. After doing this assignment, my understanding is the use of the reentrant logs. Go ahead, and any of these questions about the logs and whatnot, go ahead and post them at this point to the main page on Coursera for this Q&A session, and they'll get answered there. So let's see. A local clone should work just fine for science engine pushing. Yes, that is true. A local clone should work just fine for assignments. No need for pushing to a fork unless you're doing pull requests for assignment improvements. So that is correct. Let's see. That's true. I have private. I've never really thought about it from that perspective, but that is true. So a local, you don't need necessarily to have a GitHub account if you don't have a private repo at that point, because a local clone should work just as fine for you. But I would then at that point recommend you use GetLab and create local. Because you can import directly from GitHub, the repositories, into GitLab also, which is nice. But I would use them there as off-site storage. That way, in case anything happens to your local machine, your changes are saved somewhere, which is a good backup principle. But because I have local repositories on GitHub that are private, I had never thought about that as from an issue, but yes, during courses I always keep my information private. Let's see, how do we cancel a pull request on the Git web? Honestly, I'm not. Let's see. So the question is, how do you cancel a pull request on the Git web? And so I'm assuming you mean the GitHub website. I'm not sure if you can or not. I'd have to look into that. So how to sync automatically from the professor's repo to my forked repo for future updates? You can't automatically, because that's not the way Git was designed. Like Professor Schmidt said earlier, the guy who designed it was Linus Torvalds, and he doesn't believe in you doing things automatically. You are a computer user, therefore you should know what you want done, and it should only be done when you want it to, which normal mortals like us might not be able to handle, but we're not Linus. So my recommendation is to go ahead and, like I said in this document, I'll go ahead and bring that up to the front. Whoops. Excuse me. Do this git remote and add Doug's repository to your clone, and just do a pull whenever you start doing work on your code. That way you can handle any of the changes. So we have a question from, this one's kind of long, but is it okay to do this? So step one would fork Doug's repo in Bitbucket, clone the fork locally, then add Doug's repo as a separate remote, then to create a new branch for his solution, pull that into their private repo on Bitbucket, or push that into the private repo on Bitbucket, and periodically pull Doug's master into his master for updates. Yes, that's perfectly fine. That's a good workflow. If Bitbucket offers private repositories for free, then go ahead and use that. That's perfectly fine. Yes. So I thought that at first also. So the question here is, somebody was reading about GitLab and they believe that it requires to install the Git server on a local machine. And I thought that was true also, but the GitLab website offers functionality pretty much the same as GitHub's website, and you can just log into it for free. So you don't have to download and install a server to your local machine or a separate machine or anything like that. So when I said GitLab, I just meant their website, not the actual software that you install. Okay. Yeah, there's the rebase command. That's something to look into. I'm familiar with it. I just didn't want to discuss it in this topic. The checkout is the easiest. Another. So the question is fork versus clone versus branching. Well, that's easy. Branching is a specific thing. It's a different branch by this definition up here. Whoop, sorry. Let's select that as the question. And scroll this up to the definitions. So a branch is a duplication of the entire code. So you can have your master branch, which everybody has by default, and then you can have additional branches with complete copies of initially the master that you can do work on that are kept separate from master. So a fork and a repo, yeah, sort of the same thing, really. A fork is so a clone of the repository, aka a repo, is one that's in sync with the original repository. A fork means a repository that was originally at one point synced up with the original repository, but has now changed since then. I guess would be the easiest way of delineating them. So what are tags in GitHub? So tags, we're not going to get into. They're definitely explained in that website I linked below that explains all the features of Git. They're a nice feature, but I wouldn't worry about them for right now. So don't worry about it. Between Git Fetch and Pull. So what's the difference between Git Fetch and Git Pull? I would recommend just using Git Pull for right now, and then read on that the official documentation. What's the exact differences? So. Yes. So it does appear that you can close a pull request. I figured it could. I've never had to. So it does appear that you can do that. Thank you. Let's see. All right. I'm not seeing any new questions about it. Just some comments. Let's see. I believe we already answered this, but we might not have pulled it off the queue. But yeah, you can't prevent a pull from overwriting your work if you're in the same repository and in the same branch. So you could theoretically work in two different repositories and then manually copy the files over once you've edited them, but that's really not ideal. But I would recommend using the different branch and using the merge conflict tools. So we had a recommendation that there be a Git workflow guide. Yeah, we have discussed, and what we had originally we thought would be sufficient, but apparently it's not. So we are definitely going to take the work that I did for this document and the previous work and combine them and extend them for additional future courses. So that way people unfamiliar with Git can get a better foothold.
We'll probably also do a video.
Yeah, we'll do a full video on that, or possibly multiple ones. So. All right, let's see.
Tell people, I just linked your document into the installing and using Eclipse and Git link on the main sidebar.
So the link has now been shared inside the using Git area within the course content, so you can access it directly from there. So we have a person folders and machine, but not in the project list. Oh, so here's a good question. After a pull, what do you do in Eclipse to make it reflect the new command line interface Git version? You right-click on the project and select refresh, or by default, I believe you can just hit the F5 button and it will refresh that project. So ADX Graves, go ahead and post this question. It's a little complex to answer at this point. Go ahead and post your question in the Q&A section on the site, and we'll go ahead and try to address that. Offhand, it sounds like you perhaps pulled the projects into a workspace, and so they're not being read in properly. I'm not sure, so we'll take a look at that. So can you discuss what is going on under the hood? For example, I was surprised to learn that Git works below the file system level, actually rewriting your files and directories. So that's not quite correct either, unfortunately. It doesn't work below the file system level. Git is designed as a file system. Linus Torvalds designs pretty much everything he thinks of as a file system, Linux included. So when you're working in but he does optimizations, and that's why it's so fast. Git is designed, and I think it even says in the definitions, Git originally is designed as a source code management tool that's designed on emphasis for speed. And so using a file system and doing optimizations like that enabled such dramatic speed. When you compare Git to other source code management systems, the older systems could take literally hours to pull some portions of code, and Git does it within minutes to seconds. So that's how dramatic the speed difference is. But how it actually works under the hood, that's a topic for independent reading on your own, really. It shouldn't, I don't want to say it's not important, but it's a topic that's beyond the scope of this discussion and or class. I'll put it that way. So can you please let me know one more time how to pull from POSA 14 and push to a new repository? So when you say push to a new repository, I'm not sure what you mean, but um, in the document there's exact commands right here, and this section here of the Git documentation tells you how to work with remotes. So when you do a Git clone, it sets up your what's called an origin, which means the origin repository that you pulled from. And when you do a Git pull or a Git push, it automatically just shortcuts adding in Git pull origin master, Git push origin master. So it just makes your life a little bit easier. But the commands are right here. You just remote add whatever name you want, and then this URL here. And that will enable you to pull in work from one repository into another. Fork and a branch. Fork just means, we said this earlier, but fork just means a repository that is, it's the same as if you've ever heard somebody say that they're going to fork an open source project. It means it had a common starting point, but that they're going to deviate from there on. A branch means that it's work within the repository that is worked on for a different purpose, but might or will probably be merged into master eventually. Branch. All right, so it looks the GitHub videos for O'Reilly. Yeah, O'Reilly makes some very good computer-related books and videos. So apparently, somebody saying that they make a good GitHub / Git videos. So I haven't seen those myself, but you might want to take a look at those. Alright, so it looks like we're just repeating the same questions from earlier, or that we've run out of new questions. So we're going to go ahead and cut that short here, and hopefully this has been informative. My recommendation is just to go ahead and read the official Git book and try to understand the parts that you're using right now. So the branching and the section that I linked like multiple times on how to create a branch, how to merge a branch, how to handle a merge conflict, they're all answered in the same page. So a lot of those complex, what appears to be complex but really doesn't end up having to be complex, a lot of those issues are solved in that one page. So I would take a look at those. Okay. So the person talking about under the hood work, yes, if you enable viewing of hidden files, you'll see a .git folder within your repository. That's where all the magic happens. That's where it keeps the different versions of your files hidden, quote unquote, from the rest of your file system. But they are there. Everything is honestly files. It's just in most Windows, Linux, and Mac OS, if you create a file with or a folder that starts with a dot, it considers it a hidden file or folder, and so by default it doesn't show you them in either the command line or the file explorer. So that's where all of the different code for the compressed versions of your file, things like that, actually live. And then the files that are publicly viewable, what you normally just see, are what's outside of that. I hope that answered your question. Yes, git clone automatically sets up the remote named origin, and then when you do a push pull, you don't have to add the origin space master or anything. It just does that automatically. That is correct. Wait, let's see. Origin, which, if the source of the clone is the POSA 14 master, becomes known as the origin remote locally. Yeah, I'm not sure what the end of your question is, but yeah, the branching and whatnot explains that. Yes, there's a question. If when two people push the same repository on GitHub, they have to know the same password to access the repository. Is there a way for two people to push the same repo without one of them sharing his password? I'm not sure why in this course you're having two people work on the same code, but yes, if you're both using SSH, you can add two SSH keys, and it will say which key pushed. You create two SSH key pairs. Each person has a different pair. You put up both public onto the account, and both privates can then push to that. Git versus SVN. That is what we would call a holy war, and we're not going to get into that. Personally, I prefer Git, just because it's actually the first one I really used back when it originally came out. So. All right, I think that's about it. So we'll go ahead and finish here. And I hope that helped everybody.
So thank you very much, Mike. That was really helpful. Let me get back here a second. So as I mentioned before, I just posted the link to the document Mike was presenting to the installing Eclipse and Git navigation bar, which is on the side on the main page. So if you go to the Coursera class site, you take a look, you'll see that layer, and it has the document that Mike was presenting. If you have any more questions, please feel free to ask them. I think we're going to kind of shut down here in a second, but let me see if we have anything that. Mike, were you accepting the questions, or these things that were?
Yeah, there's a couple that I just left there.
Let's see. There's a couple more questions. Will Google change to a major language for Android from Java to something else? I have no insight into that. I would be amazed if they would be changing their languages at this point, but you never know. People do crazy things. Let's see. What are some other questions? Is there a good resource to learn about JUnit tests? That's a good question. There's probably an O'Reilly book.
To be honest, there's books from O'Reilly. There's books from different publishers. One that I can definitely say is better than the rest. No, I haven't found a definitive source.
If anybody out there listening to this has some good suggestions on JUnit test books, please don't hesitate to post them, and we'll see if we get some feedback on that. Let's see. There's some good sessions about ebooks, GitHub videos on O'Reilly. That probably makes a lot of sense. Let's see. Kind of wrapping up here. All right, I think we're. If anybody has any other questions about stuff other than Git, I'll be happy to answer them, since Mike is the Git expert. All righty, let's see. A lot of requests to make the font bigger. Hopefully, if you go back, you can look at the document which I posted, so you can read that, and you'll be able to follow along. Let's see. All right, try to get all these things cleared out, see if there's anything left. Oh, here's an interesting question. For the week 5 assignment 4, unit test was failing, but when I the value of the runtime length to 6,000. That's a good question. I don't know why it would be failing. The only thing I can think of is maybe you're doing something with fair versus non-fair semaphores, which might slow things down. You might try not using fair semaphores, so you don't actually need them for that particular test. Okay, let's see. Dell, hopefully it should be now updated. If you take a look at the installing and using Eclipse and Git, that should now be up there. If it's not, let me know. Oh, good, you found it. Great.
There were people actually viewing it.
Okay.
When I was discussing, so some people are able to hit it at least.
Oh, here's a great question from Andre. Double check locking. There's actually a great story about double check locking. In fact, there's actually the story of double check locking is available on my website. I was the editor of the C++ Report magazine back in the '96 timeframe, and I wrote a little article one time for the guest editor's introduction. I'll see if I can post it to the. Andre, if you remind me, post something to Virtual Office Hours for this week about the double check locking optimization story, and I'll post you my editorial that I wrote about the experience. Basically, I was doing my PhD dissertation work on massively parallel programming or protocols, and I had a 20 CPU Spark Center 2000 machine, and I'd been using the singleton pattern for some of the code I was writing, because this was the mid-90s, and I'd reviewed the Gang of Four book, and I knew about patterns. And I noticed that my singletons were breaking because they were having multiple calls to initialize the single object. There was actually multiple objects being initialized. And so looking into that, I realized that there was a problem with singleton, pretty obvious, that multiple threads that show up at the same time will simultaneously find the null value 0, and they'll all call the constructor. So I came upon double check locking as a way to solve this problem. And in fact, if you take a look at the documentation on Solaris for thread-specific storage and the way that they do thread-specific objects, they actually show the double-check locking optimization. They don't call it that, but that's what it is. And so I wrote up this pattern, and it solved my problem, worked really well, got published. People started to use it even more than they already had. It had been used for many years in the operating system kernel context, and which is why it showed up in some of the Sun documentation. And then people started to notice, as the newer generation of instruction processors, especially the DEC Alpha, came out, they had much more weakly ordered memory hierarchies to be able to speed up the performance of the system. And so people started to notice that double check locking was breaking. And as we started to look into this, we realized a couple things. First, singleton was designed without the assumption of concurrency. When concurrency was used, the pattern broke. Double check locking fixed the pattern, but double check locking was the assumption that the memory hierarchy was strongly ordered. As the memory hierarchy started to get weakly ordered, then which is important for performance, then double check locking broke. So there's a variety of different ways to fix double check locking. We fixed it by using memory barriers, which are described in the POSA 2 book. There's an example of how to do that. And then when people started to use it in Java, this caused all kinds of consternation for the Java community. And at first they said, oh, double check locking is bad, it's evil. But then as they looked at it more closely, they realized it really wasn't bad. It was just something that had to be supported with appropriate idioms in Java's memory model. So they enhanced Java's memory model, as we talked about last time. So now double check locking works fine as long as you use volatile and some other tricks that are described in the web page on double check locking appropriately. So it's a great example of how patterns are only appropriate when certain assumptions hold. And the more obscure those assumptions are, like concurrency or memory ordering, the harder it is to understand why the patterns stop working. So double check locking is a great example of how documenting something as a pattern made it clear that there was a need to think about this thing explicitly. And I don't think if we'd had a pattern with a name that people could refer to, we would have ended up getting to where we did as quickly, which was people fixing it and then knowing how to do it right. So that was actually a lot of fun, and I'll post that article if you want to read it. Is the signal required in the release method if the peer used signal in the acquire methods? Yes, it's really required, so it needs to be there. Is the article also available on your personal website? Donald, I'm not sure which article you're talking about, but if you're talking about the one about Singleton, yes, it's on my personal website under the C++ editorial link. And I forget exactly what it's called, but it's in there. Let's see. Can you save a single directory within a directory in Git?
Do they mean an empty directory? Yes, you can. However, Git does not even think about directories. You have to save a .gitignore file in that folder, and that file can be empty. But like I said earlier, when you create a .git file, it makes it hidden from most things.
Yeah.
And .gitignore, when it's empty, doesn't do anything. So that's the quote-unquote trick
to make a directory visible.
To make a directory actually savable.
Yeah. So what Mike was saying was if you have an empty directory inside of another directory, if you put a .gitignore file in it, then I guess Git then treats it as being something that it will know about. Sometimes you have to be a little bit careful with this. There's here we go. JUnit testing book from Johannes, link in Amazon, or watch the osherove.com videos. That's spelled OSHEROVE.com videos of unit testing. And then he also has a book called The Art of Unit Testing with examples with C++, which as we all, or C# rather, which as we all know is very close to Java. So good places to look. We haven't really spent much time on the POSA patterns. So there will be some more POSA patterns coming out in the videos that I'm working on right now. As you may know, the course right now is going in two directions at once. We're doing security, and we're also doing services. And so I'm recording some videos today after this session is done that'll talk about a bunch of the POSA patterns as they apply to communication and service frameworks in Android. There'll also be lots more POSA stuff in the last week. In fact, if you want to see previews of it, you can go to my CS282 website, which has lots and lots of stuff, but I'll put them into one format. So yes, you will get lots and lots of POSA stuff if you want it. Let's see. Are Git and GitHub the same thing? No.
Git is a technology and a software that Linus Torvalds wrote for maintaining the Linux kernel because he hated SVN, basically. And he thinks he can do everything better than anybody else, which is often true, but that's besides the point. So GitHub is just a website and a service that somebody made that runs the Git server. You can run your own Git server. And GetLab, like we discussed earlier, has a server that you can run for free yourself if you wanted to make your own personal internal Git website. So
I think the way to look at that is Git is a protocol and a set of commands, either user interface based or command line based, for being able to do manipulations of version files, and GitHub is a website that does that for you.
Yeah, GitHub, Gitbucket, GetLab, they all work the same when it comes to the website portion of them. Some of them also have servers that you can install and or clients. Like GitHub has a Windows client. GetLab, I don't know what they have, and Gitbucket, I'm not sure either. But they're all just services that use the Git protocol.
Right. When will the virtual office hour video be uploaded? So as soon as we're done, which should be any second now, in a short time you'll be able to access the raw footage on through my YouTube playlist. It'll show up on my YouTube channel, so you can go there probably in a half hour or so. It takes a while for it to upload, and then what I'll do later is I'll download that video, which has got this wonderful green background, as you can see. And then I'll split it into two videos. One will be the first part where we talk about the assignments, and then the second part where we talked about Git plus these other comments at the end. And then I'll make those into two videos and render them, put a nicer background in there. and then we'll upload those later. That'll probably be either later tonight or tomorrow. But you should be able to at least see the raw version here very shortly, where very shortly is in the next hour or so. In the simple atomic long, someone used a right lock in the constructor to initialize the data member m value. Yeah, Shing, that's fine. It's overkill. You don't need to do it, but it's not wrong. It's another belt and suspenders like approach. Here we go. Derek has an observation. Learning Git is like learning guitar. It's painful and frustrating at first, but if you put practice in, you'll achieve a level of competence. But it takes a while to become an expert. Absolutely correct. I think that it's almost like anything where it takes a while to overcome the learning curve. As Mike pointed out, and many other people have pointed out throughout the course, we're not asking people to learn something that will be a one-shot, let's waste a lot of time to learn this and you'll never use it again. If you work professionally, you will either use Git or something very much like it. And so taking the time to master that will pay off down the road for many, many purposes. On the point, GitHub is a company like Facebook or something else. So it's basically a hosting site, or SourceForge is probably another good analogy for that. Okay, well, I think we've come to the end of the session. Again, this was a long virtual office hours, and you'll end up probably with 2 one-hour-long videos, roughly 1 hour long each. As we've said before, if anybody wants to go through and create an index of the topics that are talked about and post it on the POSA wiki, that's fine. I have too many videos right now to do that myself, but I'd be happy if someone else would like to do that. So again, thanks quite a bit to Mike, who hopefully got a lot of insights about how to use Git and GitHub and other tools more effectively. And I've also been posting some responses on the Virtual Office Hours forum with responses to questions while Mike was talking. So I think we're pretty much caught up at this point. Thanks again very much, and we will look forward to talking to you soon.